Hi everyone, welcome back to my channel. Last video I have shown you what is the ResNet and what is the script connection residual, and we go through this tutorial and simplify everything. Hopefully, of course, if you have a question, just drop it down in the comment below. Sorry. Now today I will try to implement the ResNet in a freelance easy way. I will go through each block step by step so you can implement it yourself. So as you can see here, I have some blocks. For instance, I need to import the necessary libraries, and here I will implement the basic block of the ResNet, and you can see the basic block of the ResNet is like this. It has conf norm relu conf norm and the skip connection, which is plus to add the input block to the output, then taking the ReLU, calculating the ReLU. And after that, I will build the ResNet itself with the help of this basic block. And we have somehow different variants of the ResNet. So it says 18 or 34. So I will just focus, let's see, on this in this one here, and but the other one is the same. And here I will try to see how I can just test without training. It is just only a building the model, and if I just run this, it will give me a random result because the weights are not, let's say, trained correctly. So let's start with the first step. I will try to import torch, then import torch torch dot nn as. Oh yeah, so you can see there's no it's not defined, so because I have to select the kernel. So I also have, if you follow this playlist, you know how to make this environment. Now I need to add this function torch dot nn dot functional as f. So this is the most important, let's say, necessarily libs libraries that I need to I will use to build this code. So for the basic block, as I have told you, it contains these blocks here. So I need to implement these blocks. So let me just this. I will just remove this path. So now this inherited from the NN module that's inputted here. So this expansion is equal 1. This is related to the ResNet 18 and ResNet 34. And if you use ResNet 15, it will be 4. And let's define init. Cool. Init function. For the init function, we have some parameters, which is n channels, then out channels, and of course stride is equal 1. And this is stride is equal 1. So now I have write this function initialization, and now in this initialization I will create these few blocks. So self dot conf this only any. Now I will use convolution conf 2D because I have 2D images. Now image input channels, and you can see here kernel size is 3, kernel size is equal 3. Then I need the stride. The stride should be stride. I mean using this parameter here. And for the padding we will use one padding. Padding is equal 1. So it means the output has to be the same as the input. So this is the first block, and now we need to add this one here, norm. So for the norm we just need to add self dot by batch normalization. By the way, every concept here is already explained in one of the videos in the playlist. So please, if you have, let's see, if you are not familiar with such stuff, please have a look. Batch normalization 1 is equal to nn dot batch norm 2D, and then I will add this out channel, apply the batch normalization to the out channels. So the next, I will just try to copy this, and let me just, we need to be careful here. So this is the batch norm 2, and the input will be this one here. The input will be the output of the batch normalization, and we also need the output. The kernel size is of course 1, I mean 3, and the stride is a string 1 of course, and the padding is 1. So, and now I also need the batch normalization again. Someone will ask, where's the ReLU? So this ReLU will be implemented in the forward function. So of course you can do it here, but it's better to save time. So let's see, just conf2. So now we have implemented all of these blocks here. 1, 2, 3, 4. As I said, ReLU, it will be applied in the forward function. Now we need this connection here, this skip connection. How to do this? So we have to create self dot shortcut, or could also call it skip connection dot identity, and now I need to check if, so as I said, I explained in the last video. So to sum up all of the basic block plus to the batch to the output of the batch normalization, the dimensions or the length of the dimensions or the tensor size have to be identical. So if you have for instance a tensor of 1 times 2 to 1 to 30, and the other one, it has to be the C. And if not, we need to find the way how to do this to make it the same size, so we can able to we'll be able to sum up all of these. So let's see if the end channels not equal out channels. So if the input, the channels are not identical, we need to have it, this is not, we need to have to apply the convolution, one convolutional. So it's one conf. So with this I say self dot shortcut it will be n dot sequential. Okay, so what we have to do here, it's using this one here. We just use this, and I will, of course, I will change the stuff. The kernel size should be 1. Yeah, 1. Now the batch size as well, we need it. Need the batch size only this. So this is the shortcut. It's just to have it as a skip connection, or let's see, residual block. Now I think this should be okay for now. So let me just recap. So we need two conf, one, I mean conf batch, batch node, conf batch node. Then we need to add the result. So as you can see here, this is the conf batch 1, conf batch 2. Now we need to add it. We have to add the one convolutional layer, or layer with one single kernel. So now let's see, I just finished this. I need now to make a forward function. I have also explained in one video what is the benefit of using a forward function. Then it will be called automatically if you have only the model, like let's say you are in the main and you have model and you put the image, for instance, image like this, and this forward function will be called automatically. I mean, you don't need to add this, for instance, forward. So that will be done internally, which I think I like it. This is a good feature. Now let's see identity. It's is equal to the self, the shortcut. So we need to see get the shortcut of the input x. Now we have to get out. I think I have explained this also in the with the code in the previous video. So we have f dot reload. So now we will have this reload here. Reload. Then of course I can make it even much easier. Let's see, like this, equal to self dot conf 1 and then add x, then out is equal to self dot batch norm 1, sorry, then I will see out, then I will add the reload. So for this I will just add reload, it's out, right? Now you can just For instance, you can also do this in one single step, just like so. Out, then you can see reload like this, equal reload, mm, reload. Now you need to add this, and for this you need to add this. So, and this will be deleted. So see this one here, and in the beginning I have seen we need a conf one, we need a batch normalization, then we need a reload. So as you can see here, starting with the conf, then the output will be applied to the norm batch normalization, then reload. So it's the same, but just make it in a single step. Now we need to add the output, the out plus is equal identity. So identity, we have seen it. If it's the same dimension, it will be okay. If not, it will be applying the conf with with the one kernel. Or let's see, one by one times one conf. Now we need to return f dot reload, of course, out. Okay, let me just go back to the figure, to this here. I have in the initial function, I have implemented 1, 2, 3, 4. And the reload, it will be, as I said in the beginning, it will be in the forward function. So as you can see here, I have, of course, define the shortcut. Then for the reload, for the forward function, I have starting with conf1 batch norm reload conf2 batch 2, and then adding the output and then reload. So it's exactly the same as this block here. Now we need to add, so we need to implement the ResNet, and ResNet will use, of course, the block basic block, because let's see, the ResNet has 4 layers. It means four basic blocks. So let's define this, def okay, init, and this is fine. And but here we need to identify the block size, then layers, how many layers, and num of classes, just like this. Sorry, sometimes it's let's see. I mean the default function, the default class label that used by the ResNet was 1000 classes, but of course it depends on your classes. So you can just change it to 10 classes, 2 classes, 3 classes. It depends on your use. Now we will define here self dot input channel is equal 64. This is the default configuration of the ResNet. So now I also need a block. I mean this conf. So as you can see, this is the, let's see, the default implementation of the ResNet, and you can see here it's the conf 3x3 and 64. So you need to add this. Let me just copy this because typing it takes time, and we need to change the parameters. Okay, be self. So the conf parameter, the input should be channel because it's the image. Now we have the output. We can use self in channel or 64. I'll just use 64 because it's 64. And the kernel size, it applies to this, it was 7 because it's not just mentioning key. And the stride is 2. And the padding is 3. So this is only a default stuff. So they use this. I mean, of course, they have experimented several configuration, but this is the best. Let's see, they got the best result with this config. Because I also sometimes when I need to do something, I need to do many experiments on different configuration, and I just pick the latest. Let's see the best one. So, okay, no, this not. We need the batch normalization. Let me just copy it from here. Okay, now let me just see. N channels is 64. And what? This is output indeed. Output. And this is N channels. It's the same as this one here. Input channel and but the input channel here is 3 and the output is now we need to have on the 64. It's bad implementation, I think, but it's fixed. So why not just using this? And let's see, self dot out channel 64. Now we need max polling layer. It's not clear here, but self dot max and then dot max poll 2D. Kernel size is 3. 2 or 3. I have no idea. Let me check. Okay, before doing any issues, I have an idea. Let's see. I have imported this. Now I need to see the original model how it's looking. So as you can see here, the first conf layer, it has 364 kernel 7 by 7, 2 and 3, and the batch normalization is this one, and the max polling layer, max polling, it's 3 stride 2 and deletion 1 and 1. So we can just use this. So with the conf 1, let's just copy this. Why not? So okay. We save the time. Okay, and now if you see the blocks, after this one here, it has layer 1. And the layer 1, we will try to use the basic block. And the basic block, of course, it has all of these layers. Okay, so let me just pause the video and write the function that will create the layers, and I will back to you because it might take much time. Okay, so like I can see I add this code here, and let's explain this. So as you have seen in the printing, it has several blocks. One, this is the first one. It has two blocks, 1 and 2. This one is also the same, 0 and 1, and etc. And the final one, let me just see this, if we can see the whole stuff. Wow, interesting. Okay, let me just down. Here the first layer, it has two basic blocks. The second one is the same, the second, the third, and the fourth, but of course with different size and different shape. And finally, they have adaptive polling layers. So let's have a look. So I also had adding this in the ResNet 18. I have seen 10 classes. Now the basic block, for each block I have for each layer I have two blocks. Now as you can see here, this is the first layer. The block and the output size is 64, and you can see in this one here conf64, and the output will be 64. I mean after the batch normalization. Now we will see, we will have this block here, but let's see, shrinking the images, I think not the images, shrinking the features map by 2, and but increasing the channels. And if you see, hopefully it should giving some more info here. Oh, is this? You can see 64 for instance, and here it's not here. Input output, and it's increasing the size of the output. So here it was 64, and here is 128. And with the same stride, the stride will be here 2 2, as you can see. This is 1, and the padding will be 1. So this is for instance making the layers based on this initialization here, if we would like to initialize the blocks. So we have 4 layers, and each layer has different has 2 blocks. And let's see let's have a look how the layer the function is making the the layers. So the function is create a sequence of blocks, and the first block may adjust the both number of channels and the resolution, depends on the stride. And this operation will be the same. For instance, here just adding pad, let's see, append layers from the block. So for instance here we have the input channel, and here's the output channels, and adding layers. And here it's just in each block we will add two layers, because here we have several blocks. See, I mean we have block 1 2 3 4, I mean layers, and in the block we have only 2. Okay, so after creating the layers, then the final step is average polling, which is, you can see it in here. This is the layer 1, this is layer 4, and this is the average polling layer, of course, plus the fully connected layer. Now this is, let's see, not done, but almost. So this is only creating the layers. Now we need the forward function. Def forward function self. Then we have x. Oops. So for this, we need x is equal to f dot reload. As I said in the beginning, we can just use self dot n1. Then the input is self dot conf1. Then we need x is equal self dot max pool. Now from this you can see the forward function is including everything here. Conf, batch, reload, then max polling layer, and of course then layer 1, layer 2, layer 3. So sorry for this conferencing. So maybe it's not in the same place, so you can see it every time. But yeah, self dot layer 1, and from this layer 1 it will go to the H block, and then copy layer 2, layer 3. I also have a video on how to use ResNet for transfer learning and also for feature extraction. Yeah. So please have a look if you have time. Self dot average pool. This is the last one, and now we need to have flat. X is equal torch dot flatten x. Okay. Then we have self x self dot where's a fully connected layer? Here. The fully connected layer x, then return x. So now it's finishing, let's see, the implementation. So if I have to click, let's say, run the everything from scratch, let me just remove this. It's not needed anymore. And this, then this class. So now we have, let's see, 10 classes. And the output I'm expected, it should be 10. Okay. Okay, let me just check. I'll be back. Of course, I will tell you what is the error. Yeah, so the error was here. I have added this dilation. I just copied from here. So from when I show this model, I just see the max polling. I just copy this line here and was wrong indeed. Okay, good to know. And now let's see, run, run and run nochmal again. Okay, now let's see. Oh, the conf one has no input. Interesting. Is it? Hey, which couldn't be indeed. So again, returning conf one. Okay, let me check. Sorry, find the error. So let me just show you what I have done. So let me start from the beginning. Yeah. So as you can see here in this file, I have forgot to add the bias is disabled in this one here. So what you can see here, it's just like making I mean taking some information from here, and you can see his bias is false. And what I have done, the default is true, and this one here. So as you can see, I have even made some mistakes, but it's also it's a good also to learn how to code stuff. Even me, I have as you said, I have done many let's see bugs, but at the end I know how to fix this. So and this is the goal. And they have add for each conf, just bias is false. And for the max pool, if you see here, max pool layer, it was, where is it? So I have mistype of this. So you can see max and poll 2D, which is has to be max polling. And the rest has to be the C. That's it. And let me just run this again, run all. You can see it's already finished. So the output of the shape is 1 to 10. So this is the probability of the classes. But please keep in mind this ResNet, it's not trained with any, let's say, real data. So the weights are initialized randomly. So that's why you will have any random result. So if you see print output, just printing the output, you can see here this is the probability to these classes that you have in we have trained in our stuff. But as I said, this is only a normal random weight, and to use now this, you have to add the training stuff. So I have done this with the transfer learning. I hope you can. Oops. I hope you can see this transfer extract. This is the extraction and transfer learning. This one here. So you need just to copy the parameter. This is the classifier I have done. This is the transfer, and here you need to copy this stuff and put it in. Of course, you need to load the data and everything. And this is the code for training. Okay, that's it for today, and thanks for watching, and see you next time.